Hello everyone. In this video, let's discuss how to write a program to find sum root to leaf numbers. You are given the root of a binary tree containing digits from 0 to 9 only. Each root to leaf path in the tree represents a number. For example, the root to leaf path 1, 2, 3 represents a number 123. Return the total sum of all root to leaf numbers. Test cases are generated so that the answer will fit in a 32-bit integer. A leaf node is a node with no children. So here they have given an example saying that 1, 2, 3. So here 1, 2 forms a number 12 and 1, 3 forms a number 13. So 12 plus 13, the output is 25. So this is what we have to print as the output value. Let's go for the next example. So here root to leaf we have 495 forms a number 495 and another path is 491 forms 491 and another path from root to leaf is 40 forms a number 40. So if I add all the three numbers, I'll get my output value as 1026. So this is all about the question. Now let's discuss the logic in detail. So here we have given a binary tree. So the logic is pretty simple. Obviously whenever we solve a question with the help of trees, we have to deal with recursion. So first let me define the method. Public, this method has to return an integer value int some numbers. So here we have passed tree node, that is root value has been passed as my argument. So I'll take here, I'm going to take a method. So I'm going to call a method because we have to find the sum value, right? For that I'm going to pass it as an additional argument. So I'm going to give the method as return. I'm going to give the method name as helper. So helper root comma initially the sum value is 0, let's assume. Okay, if the root is empty, I can return the value 0. If the root is not empty, actual sum value has to be returned. So let's define the method called helper now. So I have called a method. That method has to return me an integer value. So I'll give the return type as int helper. So here I have passed two arguments, root and another one is sum. Okay, fine. Here whenever you go for 1 node, you have to make this number as 49. You should not add 49 makes 49. Next 49 and when we are concatenating 5, it should be 495. For that also we have written one condition. Okay. So before which we have to go for the base condition. So what is the base condition we always write? If the root is equal to null, we have to return 0. That is the base condition. Okay. What if root is not equal to null? If root is not equal to null, we have certain value in the root. So I have to take that value and I have to form it as a number. So I'll take sum equal to sum into actual sum into 10 plus the current value, root value. So root dot val. So here what are we doing? We are concatenating the number and forming a actual number. So 4 and 9 concatenating together forming a number 49. So that is what we are going. So initially sum value was 4 in the sense 4 into 10 which becomes 40 plus root dot val 9, 49 becomes. So when we are traversing these two nodes, initially sum value was 0, 0 into 10 0 and the actual root value will be adding. This is how we'll go for it. So now root is pointing to the node called 100. So let's assume root is pointing to the node called 100. Check root equal to null? No, root is not equal to null. If root is not equal to null, I have to take the node's value that should be added to the sum value. So here sum is initially 0. Okay, I have called a method helper. So here what I have passed? I have passed the root value is 100 and I have passed my sum value is 0. Now I am working on this method. So in this method, I am checking root equal to null, no. So now I am finding my sum value. So sum value is 0 into 10, 0 plus root dot value is 4. Now sum value is 4 in this function. When I am working on this function, sum value is 4. After this, I have to check whether this node is a leaf node or not, because until the leaf node I have to iterate. So how can I know whether the node is a leaf node? If the left child is null and the right child is null, both are null, I can say that particular node is a leaf node. So if root dot leaf equal to null and root dot right equal to null. So if both the conditions are true, what does it mean? It is a leaf node. If it is a leaf node, I have to return the sum value. Okay, fine. So here check whether root dot left is equal to null. No, so it is not a leaf node. So I have to traverse the left child, I have to get the value, and then I have to traverse the right child and I have to get the value. So what I'm going to do is I'm going to call two recursive call, which is return. I'm going to write the recursive call for the left child. So helper root dot left comma sum plus right child helper root dot right comma sum. That's all. This is the logic of the program. So here I have called a method. Now sum value is 4. So this node is not a leaf node. So I will be calling the left recursive call. When I call the left recursive call, the left child value is 200. So helper 200 comma, in the function helper of 100, the sum value is 4. So 4 will be passed as my argument. Now currently I am standing on this particular node. Now check whether root is equal to null. No, root is not equal to null. I have to concatenate this 9. That should make 49. So sum is 4. 4 into 10, 40 plus root dot value is 9, 49. Now sum value becomes 49. So in the function helper of 200, sum value is 49. Now check whether this is a leaf node. So root dot left is equal to null. No, it is not equal to null. So this is not the leaf node. So I have to go to the left child. So I have a recursive function called for left child. So I will be calling helper. So left child address is 500 comma sum value is 49. So I will be going to this node called 500. Now check root is equal to null. No, root is not equal to null. If root is not equal to null, take the value from the node and concatenate with the actual sum value and make it a number. So here root dot value is 5. So sum value is 49. 49 into 10, 490 plus root dot value is 5. So becomes 495. So in this function sum value becomes 495. Fine. Now check whether this node is a leaf node. Root dot left is equal to null. Yes. Root dot right is also equal to null. Yes. Condition becomes true, which means this is a leaf node. Now what I have to return? I have to return the sum which we have got from the function 500. So from the function 500 we have got the sum value as 495. That will be returned to this particular place. Why am I returning here? Because from this node left child I have called. When I call the left child, the sum value is 495. So I have returned the value is 495. Now what I have to do? From the function, so this has been returned to this place. Okay. In this function, I have called left child and I have returned the value. Now I have to call the right child. So in the helper of 200, okay, I have called left child 500. I have got the value. Now I have to call the right child. So helper right child address is 600 comma sum value. What is the sum value? In helper we have got sum value is 49. 49 will be passed as my argument. So now currently root is going to point to this node. So check whether root is equal to null. No. Now find the sum value. Sum value is 49. 49 into 10, 490 plus 1, 491. So in the helper of 600, sum value is 491. Check root dot left is equal to null. Yes. Root dot right is also equal to null, which means this is a leaf node. I have to return the sum value. The sum value is 491. 491 will be returned from the right child here. So this will be returning to this place as 491. Okay. So this value has been returned to this place. So in the helper of 200, left child also over, right child also over. What I have to do? I have to sum both the values and I have to return 495 plus 491. The sum value is 986. So that will be returned by the helper of 200 function. So that will be returned here. 986 will be returned here. In the helper of 100, left child got over. Now I have to call the right child. So here what I will be doing? In the helper of 100, left child got over. Now I have to go to the right child. So I have to call this recursive call, which is helper of right child address is 300 comma. What is my sum value? My sum value is 4. Okay, I have called. So currently I will be standing on this particular node. So now when I am in the right child, second recursive call will be called. Fine. Now I have to check whether root is equal to null. No, root is not equal to null. So I have to find the sum value. So sum value is 4. 4 into 10, 40 plus 0. The value is 40. So sum value becomes 40 now. So in this function, sum value is 40. Now check whether this node is a leaf node. Root dot left is equal to null. Yes, root dot left is equal to null. Check root.write is also equal to null. Yes, root.write is also equal to null, which means this is a leaf node. So the sum value has to be returned. Where I should return? The sum value will be returned to the right child of this method. So here I will be returning the value called 40. Okay. So now left child also over, right child also over. I have to sum these two values. So the value will be 1026. So 1026 will be returned as a final output. So here this 40 will be returned. So this function will be removed. Now this helper 100 will return the value called sum of these two values, which is 1026. 1026 will be returned as my final output. Okay. So this is the logic of the program. Let's try to implement as a program. So here I am going to call a method called helper. I am going to pass a root and some value initially is 0. So whatever this method is returning, that has to be returned from this function. So I'll give return keyword here. Fine. Let me define the method. Public, it has to return an integer value. So int, the method name is helper. Tree node root comma int sum. So here first I have to write the base condition. What is the base condition I am going to give? If root is equal to null, I have to return 0. Okay. Next, if root is not equal to null, I have to concatenate the value and that should form a number. So for that, sum equal to sum into 10 plus root dot val. So now we have formed a number. After forming a number, checking whether the node is a leaf node. So how can I know? If root dot left equal to null and root dot right also equal to null. If the condition is true, I have to return the sum value. If it is not a leaf node, find the sum of left child and right child through recursive call. So I am going to give return left child. So helper root dot left comma sum. This should be added with helper root dot right comma sum. Done. That's all. This is the logic of the program and this is the implementation as well. Let's run the code now. Yes, it passes the test cases. Let's submit the code. Yes, it passes all the test cases. That's all.